So, activation functions in neural networks. Before we get started, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. Activation functions are mathematical functions that determine a neuron's output based on its input. Each neuron receives weighted input signals, applies the activation function, and passes the result to the next layer. These functions introduce non-linearity into neural networks, enabling them to learn complex patterns without without nonlinear activation functions. Even deep neural networks would be equivalent to simple linear transformations, severely limiting their learning capacity. So, how do you understand these? So, we'll go through a couple of them, but make sure to share. All right. So, linear activation function. All right. This simply returns the input changed. It provides no non-linearity and offers no practical benefit for neural networks. You won't see it in SageMaker or AWS frameworks. Then you have something like binary step functions, which this isn't it, but it's okay. So a binary step function's output is 1 if it's positive. Otherwise, it's 0. While historically significant, it's not differentiable, right? Which breaks back propagation. So they're impractical for modern deep learning and aren't used in AWS tools. Then you have something like Sigmoid. This is also called a logistic function, right? So this squashes inputs into a range between 0 and 1 using a formula. We're not going to go into the formula, but just know that. It works well for binary classification and multi-label problems where multiple outputs can be true simultaneously. However, Sigmoid suffers from vanishing gradients in deep networks and is computationally expensive. In SageMaker, you'll encounter Sigmoid in built-in algorithms like linear learner for binary classification tasks. Next, you'll have Tanh, all right, which is a hyperbolic tangent, right? So it outputs values between 1 and 1, or I'm sorry, -1 and 1. Its zero-centered output leads to better convergence than Sigmoid, making it superior for deep networks. It still suffers from vanishing gradients, but works particularly well in recurrent neural networks. When configuring custom models in SageMaker Studio notebooks, Tanh frequently appears in NLP tasks using RNNs or LSTMs. Then you have ReLU, which is rectified linear unit, right? So this is outputting 0 for negative inputs and the input value for positive inputs. So its computational simplicity and ability to avoid vanishing gradients for positive values makes it the default activation in most SageMaker deep learning containers. The main limitation is the dying ReLU problem. Neurons can stop learning if they get stuck outputting only zeros. ReLU serves as an excellent starting point for feed-forward neural networks. Then you have to calculate, let's see. This is another one, but whatever. A leaky ReLU. So this fixes the dying ReLU problem by allowing for a small slope for negative values. All right. You use leaky ReLU when standard ReLU shows poor convergence. You can implement it in custom TensorFlow or PyTorch models within SageMaker. Then you have parametric ReLU, which extends leaky ReLU by making a learned parameter rather than a fixed constant. So this flexibility comes at increased computational cost. Use preLU in deep networks where standard ReLU underperforms. It's available when combining custom PyTorch models in SageMaker. Then you have ELU, which is exponential linear unit. So this uses exponential decay for negative values rather than linear slopes. Okay, it provides smoother transitions than ReLU, but computes slower. Consider ELU for deep networks benefiting from smoother negative activations. Then you have Swish. Swish multiplies the input by its sigmoid. Google developed it for very deep networks, think 30, 40 plus layers, right? Where it shows excellent performance. It rarely appears in AWS examples and is more common in TensorFlow Hub or DeepMind models. All right, while ReLU is technically a special case, the double parameters for something like max out helps to make it inefficient. It's not widely supported in SageMaker or Jumpstart models. Then you have Softmax, which converts a vector of values into probabilities that sum to 1. It's specifically designed for the final output layer and multi-class classifications where the model must choose one class from many options. You'll find Softmax in built-in multi-class classification algorithms like XGBoost, Linear Learner, and custom Keras models. All right, so choosing the right one. All right, let's go back and save some of these. So your choice depends on the problem and the network architecture. Use Softmax for multi-class classification output layers. Use Sigmoid for multi-label classification, where multiple outputs can be true. Use Tanh for recurrent neural networks. For feed-forward networks, start with ReLU, move to leaky ReLU or preLU if you encounter dying neuron problems. Very deep networks may benefit from Swish. All right. And costs. That's one thing. So activation functions directly impact training costs. ReLU and leaky ReLU compute fastest, keeping costs the lowest. Sigmoid, Tanh, and Softmax require exponential and trigonometric calculations, making them slower and more expensive. Prelu and max out add learnable parameters, increasing both compute and memory requirements. Since SageMaker training jobs bill hourly, activation function efficiency affects your total training costs. So let's get a little tinkering around. All right, so we would go into SageMaker. Let's see. We'll go to Jumpstart. Let's see, foundation models. Let's see. All right, let's select the. Oh, this is going to cost. Okay, so you can open this model in the studio to load it. So this will, gosh, it's going to take too much time. All right. So basically, you would open this in the studio, configure it in your SageMaker Studio environment. Then you could look at the model's config or training script and confirm which one of the ones we just spoke through appears in the hidden layers. So this will typically show the default for any layers, and then you can verify it, be able to modify it if you want to experiment with different functions, and then you can edit the script to replace certain ones like ReLU with leaky ReLU with pre-ReLU. All right, and you can launch the training job. But unfortunately, we're not going to do that just because it's going to take too much time. I apologize. So if you run multiple experiments with different activations, once you go through this, you can use SageMaker experiments to track and compare the performance metrics systematically. And you can also monitor this in CloudWatch as well. Okay, so like for a specific example, let's see, we can go back, close this. All right, so which one? Let's see. Does this have? All right, so this one would have XGBoost. All right, be able to view this model. And so you can select this one as a multi-classification job, right? So in here, you can update the hyperparameters like we were doing in the built-in algorithms for those training jobs. You can set the objective parameter to a different type, like multi-soft prob, and that would ensure that XGBoost uses Softmax for output, right? So this would be a nice configuration once you open the model in the studio. And then you could have this distributed across multiple classes rather than just the predicted class label. All right. So for the exam, a couple of points. Activation functions introduce non-linearity, enabling complex pattern learning. ReLU, I didn't spell this, ReLU, but I think you probably saw it, is the default for most deep learning applications in SageMaker. Sigmoid works for binary classification, Softmax for multi-class. Tanh, which is T-A-N-H, suits RNNs due to zero-centered outputs. Vanishing gradients affect Sigmoid and Tanh in deep networks. Dying ReLU can be fixed with leaky ReLU or preLU. And computational efficiency affects training costs. So remember that ReLU is fastest. And finally, Softmax must be used in the output layer for multi-class classifications. So when the exam questions ask about output layer configuration or classification, dealing with vanishing gradients, or choosing activation specific network types, understanding these activation function characteristics will guide you to the correct answer. Anyways, that's all from us today. Thank you for joining. Remember to hit the like button, subscribe, share this with anyone you know taking the AWS Machine Learning exam. Have a good day.